Go ahead and read our announcements for us.
Okay. Learning objective. I can prove polygons are similar and calculate and use scale factor. Today's agenda, do not turn in page 362, warm up, and then the flagpole height problem. Homework, page 362, numbers 1 through 13, and hold that till Monday. Pages 363 through 364, and you probably do numbers 21 through 28, 31 through 32, and 34. That's due Wednesday. And then basic skills, area, perimeter, volume, that's deadline for that, so Friday the 1st. Others, Math Nation, test yourself section 4, no later than Sunday, January 21st at midnight.
Thank you. All right, I've seen some of your pictures. You're on the right track, most of you. So keep working on those. I'll come around and check. You don't have to do the calculations. The drawings are what we want right now. So once y'all are done with the drawings, practice trying to sight in like one of those lines on the ceiling. Try to sight it in and see what the angle of elevation you think would be. You can help each other. You might have to hold it, and she might have to look at the number where it crosses the number. And then that flagpole and shadow. You better to keep, like you did this, the ground horizontal. You better have the shadow on the horizontal. And then you need a stick, drawing the stick also. Suggestion would be to keep the ground always horizontal on your paper. You can use the blue lines to keep your drawing consistent with the ground being one of the blue lines on your paper. Where's the stick? Yep. The second drawing you have two things. You have a flagpole with a shadow. You also have a stick with a shadow. Ah. What's that? Sort of practice trying to sight in like one of those metal lines and see what you think the angle of elevation would be.
Oh!
Why would the shadow start over here away from the stick? This is the shadow stick. Okay. Why would it start here? Why would there be a gap between the stick and the right end along this line, one of those metal bars.
Like, don't hold it until like, and then like push it down slowly.
Y'all get one? I had to get one. I didn't get it. Oh, that's you. calculations, we may handle those later. As we work, we're going to form some groups, and people are going to go out and measure some things. So I want to make sure we have the pictures right first.
This is a 60 degree.
Let's see, who thinks they have a good picture for the first one?
Tammy? Oh, yeah.
For the first one,
Okay. Thank you. So what geometric shape is involved? Triangle. Can we be more specific?
Right triangle.
Right triangle. All right. So let's critique the picture. Let's analyze this, see if we can improve and help if needed. Anybody have any ideas? Was 62? Leo asked you, where did the 62 come from?
Elevation.
Okay. Was it 62 feet?
Pretty sure it was 50 degrees.
Yeah, it's degrees.
Either.
degrees.
Okay, it was degrees. So when you sight something in, like these devices you have, these can measure angle of elevation. When you sight something in, you get an angle. So we can improve a little bit on that. We can change the 62 to degrees and change its location. You might want to draw the triangle first. So we can, I saw some of you have a triangle like that, as well as the ground. It's a good idea to have the ground and the triangle. And then the 62 is measured as the angle of elevation we've learned goes from horizontal, you start going up 10, 20, 30, 40, 50 until you get to the angle where you sight in the top of whatever you want to measure. So 62 degrees would go there. Any other suggestions?
What's the 37 up to the side?
It's a 35.
Oh, I was thinking that.
Were you doing some calculations or?
Yeah, it was what the thing.
Oh, she was playing with her
Oh.
device to measure to the ceiling. All right. That's good. Anybody need that to improve yours? Anybody not done fixing theirs if they need to fix theirs? All right. Anybody want to volunteer for the shadow crumble? Some of you drew some really nice flags and all that stuff, which is good, but of course a simple might suffice or even be better. Let's see. Any suggestions?
Simple. Where'd you get the 3 feet from?
It's a yardstick.
Hannah said it's a yardstick. That's where she got the 3 feet from.
Okay.
That's very smart.
Where'd you get the
36 inches.
Okay,
The same.
Zach said he's 36 inches. So let's see, what do you think would be better? 3 feet or 36 inches?
36 inches.
That's because it's
More
Ah,
precise.
3 feet.
So some people think the inches would be better, some people think the feet would be better.
I say it's the same as the original.
Hey, Tristan suggests we keep it the same as
The original metric system was used for flagpole.
the original measure for the flagpole.
That way you don't need to mix it all over.
Does that make sense? Okay, we want units to match up, so if we need to do calculations later, maybe simpler. And then, any other suggestions for improvements?
Wait, isn't the 20 feet supposed to be for the flagpole or not the shadow?
Hannah wanted to improve her own, that's good. She said she could have put the inches there to make that more clear. And Leo had a question, what?
The 20 feet.
Yes.
Is that supposed to be flagpole or shadow? Because it looks like it's for the shadow.
It said that it was a shadow.
Hannah said the 20 is the shadow. It said it was the shadow.
What's it?
Yeah, it said shadow, yes, it said the shadow, 20 foot was the shadow. So, shadows are horizontal here. Some of you drew them sort of an angle. Maybe you're a better artist than I am or whatever, but you're thinking 3D and you drew a nice little picture of a shadow at an angle and all, but to keep it consistent, you might have just wanted to use the horizontal as the ground, and the shadows are on the ground horizontally to keep your picture simple.
Is there, can you check if it did say shadow, because pretty sure it did.
Sure.
It did.
It's right over here on my screen. It says shadow. Did it say 20 feet for the shadow? It says the flagpole, measure the shadow of the flagpole, and it is 20 feet long.
Yeah, but did you say that you measured the shadow with some other stuff? Like after that?
There was other things after that, but that was all about the flagpole. It measures. So that may be a little bit unclear, right?
Yeah.
John measured the shadow of the flagpole, and it is 20 feet long. The pronoun it. Why did most people think it was a shadow and not a flagpole?
Because it says the shadow height of the flagpole.
Okay, Hannah says because it said to find the height of the flagpole.
Okay.
Good idea. I didn't think of that one. Anybody have no idea why it might need to be a shadow? Practically, if you're going to go out there, do you think a person would want to climb up the flagpole or measure up that? Probably not. So I could have been more clear in my directions. Good job. So we can good critique of myself and the drawings. There are some geometric shapes here we want to include, so we can finish this picture by including a geometric shape. Talk with your partner and see what shapes we could make out of these two pictures, and then I'll ask the group to give me your idea. Talk with your partner. Basic geometric shape, there are going to be two of them. Shadow of the stick. Yeah, the shadow. Shadow and comma, which is all right, Danny, what did your group think?
Maybe make triangles.
Make triangles. All right. Very good. Make triangles. Would they be guaranteed to be right triangles?
No.
Yes.
Yeah, because we got to look.
Unless the flagpole's tilted.
Unless you have a hurricane, knock the flagpole sideways or something. So we'll assume that the shadow's on the horizontal ground, the flagpole is straight up and down, and when you hold the yardstick, hopefully you're gonna hold it where it is
It said vertical.
vertical, right?
You can make a right straight.
So how would this relate to what we just doing just now?
We're trying to find the height of the flagpole. Also.
What's our topic?
Angle of elevation. Solution.
Your homework.
Oh, hold on. So,
Scale factor. Are the triangles similar?
Yes.
Because
They have
they have the same angles. The sun is shining, making an angle of elevation of the sun is here. If you sighted in the sun. So you got angles that are all the same, making them similar. Okay, so we are going to learn to use these little measuring devices and go out and measure a tree this time. And we're going to measure the angle of elevation. We're going to do it two different ways, just like these two problems. We're going to learn to use trigonometry like problem 1 would require, and we're going to use shadows and proportions for this second one. So we'll have a group that goes outside, does some measurements. Don't give away your measurements because we want to see what everybody gets and how close they are. So keep your measurements secret. And as they're outside measuring, we'll work inside to trying to get the answers to these two problems and make sure we know how to do the calculations. So take your device here, the protractor with the string, and point it at one of the metal beams up high. And have your partner help you try to read off an angle degree. You don't want to obstruct. The string needs to be moving with gravity and let it hang straight down. Sight your eye right along the edge. Straight. Help her by looking at me. So you're pointing at something up high. Do you think the angle should be large, close to 90, or small, far away from 90? Small. If you're pointing up high.
Oh, like straight up?
Oh, pointing up.
Yeah, like straight up, that'd be 180.
We're all pointing up high toward the ceiling.
It'd be smaller, because as the point goes higher, the angle gets smaller.
Yes, the angle gets smaller, but if I asked you if you didn't have this in your hand and you want to know what's the angle of elevation, something up high like that, would you expect to be close to 90 or not? Yes, it should be. So we have to learn, this is a makeshift device. We have to learn how to use this device. Did you get a small number or a bigger number? Smaller. You should have gotten a smaller number.
I think we got like 50.
So we have to do something to that number to make it work. It's not the correct angle of elevation. What are some numbers you got? Just holler them out.
55.
55,
28.
28,
51.
51,
50.
27,
50.
57,
I'm for real, like, oh, 50.
30. I was expecting you to get smaller numbers. Maybe some of you didn't go up high. Maybe you went more forward to the front of the ring. So this is upside down. You're holding it upside down. Your line of sight is running along here, and the string is hanging down vertically, like that. So you get something there, 40, 50 maybe, but that's not the correct angle.
It was like 40.
Since it's upside down, we have to do one calculation with subtraction. We got to subtract this from a certain number. Number minus 57 to get the correct angle of elevation. Talk with your partner, see if you can get the right number to put there. Trying to get the correct angle of elevation. This is upside down, so we got to do something to the number you got from the protractor.
No.
There's a number you need to subtract it from. I'm asking for the number.
Well, oh, we have. You're right.
All right, Ashton, tell me what you got.
I got 33. I mean,
No,
90
the number you're supposed to subtract from forever.
90.
90. Tell us why you thought that. Why did you think 90 maybe?
Because you have to flip it to the other side. Look where it is.
Okay. So we're sort of upside down, and so what you actually found was the angle up here, which is not the angle of elevation, because the protractor's upside down. So we've learned the corollary where these two angles always add to 90. You need to convert it to the angle down here.